All right, this video is going to be on the trigonometry inverse. So instead of the trigonometry basics where we're looking for a missing side, we're now looking for a missing angle. We're looking for theta, okay? So here we're going to be using inverse trigonometry, which is a button. And honestly, I think this is the easiest one. I'm going to be completely honest with you. I think this is the easy. I think finding a missing angle is easier. So first, we're going to go ahead and take a look at this. Remember that H is for hypotenuse, O is opposite, and A is adjacent. What we should be noticing here is the change. What we have here is a -1 exponent. That is the inverse of these trigonometric functions. Okay? So we're seeing this -1. So in the calculator, we're going to use a different function as well. We're not going to use the sine, cosine, and tangent, but they're right by them, okay? So let's go ahead and write these and let's just jump straight into it, all right? Finding our reference angle where theta is, right here. In my last video, when I tell my students, I always like to look across and see if I'm using my hypotenuse first, okay? And I am, so here's my H. And then sitting at theta, I'm going to notice that the 2 is adjacent, right next to. So here's my A. So A and H is going to be your cosine. So this, I just go ahead and start it off like this. And honestly, you can jump straight into these formulas as well. Usually on formula charts, that's not given to you though. So I'm going to show you what happens if you don't have those formulas. I'm going to go ahead and set up my equation here. I'm using cosine. So instead of putting a number now, you're going to have cosine of theta. Okay, you just draw a 0 with a little line through it, because that's what the angle measurement is. This is going to be equal to adjacent over hypotenuse. So adjacent 2 over the hypotenuse of 5. What ends up happening is the inverse comes in and wipes and takes away that cosine. So you're going to end up, that's how we transform to the inverse, where we have theta equals the inverse cosine of 2 over 5. Okay? So here's that inverse. I'm going to kind of highlight the first couple here. So in your calculator, this one I don't think it tells you what to round to. We'll just round to the nearest degree. A lot of times it'll be round to the nearest degree with angles, not always though. So in that Desmos scientific calculator, okay, for those who did not watch the previous video, if you look up Desmos, D-E-S-M-O-S, scientific calculator, it's going to be this cubed root of 27, this green one right here, okay? This is the best one, in my opinion, to use at home if you do not have the graphing calculators at school. So we need to type in this inverse cosine of 2 over 5. So we're going to go to the function where our things are. Look, right underneath sine, cosine, and tangent are the inverses. So all you got to do is press that. Go back to main. Your fraction function, that a over b, type in 2 on top, down to the bottom, press 5. Voila, there's your answer. You're done. So we're going to round this to the nearest degree, so it would be approximately 66 degrees. All right. Please rewind if you need to see that again. All right, number 2. We're going to take a look at, if you've already done special right triangles, you may already know what the angle measurement is here. Here's our reference angle. I'm looking, see, I'm not using my hypotenuse. So from the reference angle, opposite side and adjacent, right next to. So I'll be using cosine again. I'm sorry, I am not. I'm using tangent. So again, not using hypotenuse, it's automatically going to be tangent. Opposite over adjacent. So over here, we can just jump straight into this if you want to, okay, saying that your theta is equal to the inverse tangent, so tangent to the -1 exponent of, in your parentheses, we want opposite 8 over adjacent 8. And you can simplify these fractions if you want to. If you plug in the inverse tangent of 8 over 8 and the inverse tangent of 1, you're going to get the same thing. Okay, and I can show you, I think there might be, there's not another one on the notes I can simplify, but you can simplify them if you'd like to. Okay, so in the calculator, jump straight over here. We're going to go ahead and clear all. I'm going to go to my functions, and I'm going to find my inverse tangent, making sure it's on my screen. Go back to main. We have our A over B fraction function. Put 8 on top and 8 on bottom. And we're going to get 45 degrees. So I'm going to show you, even if you simplified it to 1 over 1, you have your inverse tangent, back to main. If you simplify it down to 1 over 1, you get the exact same thing. Okay? So this isn't even approximate. This is, your theta is exactly equal to 45 degrees. There's no rounding on that one. All right, we're going to pick up the pace, shorten this video. Please pause and rewind if you need to. All right? Number 3, theta. Next, we're using H, hypotenuse. Yes, we are. Then stand at theta. 6 is on the opposite side. O. O and H are sine. So we're going to be using the sine function. Straight into this formula right here. Theta is equal to the inverse sine. So theta is equal to inverse sine of opposite, 6, over hypotenuse, 11. Straight back to the calculator. I'm just going to get it all cleared out. I'm going to go to my function, inverse sine, back to main, fraction, 6 on top, and 11 in the denominator. We're going to be at approximately 33 degrees. Next, reference angle is theta, hypotenuse, yep, you're using it. And then 15 is on the opposite side. So O and H is sine. So we're going to set this up directly into theta equals the inverse sine, okay, this one right here, the inverse sine of, parentheses, opposite, 15, over over hypotenuse, 41. Plugging into our calculator. We're going to have, go into functions. We're going to go to inverse sine, back to main for our fraction function, 15 in the numerator, 41 in the denominator. Theta will come out to approximately 21 degrees. Not the color I wanted, because my OCD has to be perfect. All right, 2 more quickly. We're almost done. Reference angle, angle of perspective. Hey, check out the hypotenuse. Yep, I'm using it. There's my H. Staying at theta, 14 is adjacent. Next to A and H goes with cosine. Cosine is adjacent over hypotenuse. So we'll take our theta is equal to the inverse cosine of adjacent, 14, over hypotenuse, 19. Go ahead and make sure that we see this in the calculator, just in case we need to. Function, inverse cosine, back to main, that A over B, 14 goes in the numerator, 19 in the denominator. So we're going to be at approximately 43 degrees now, because the 5 in the tenths place is telling us to bump that 2 up. All right, last one. Here's our angle of perspective, theta. Crossing the crossing the right angle, we are not using the hypotenuse now. Automatically using tangent. Staying at theta, opposite side, the 23. And right next to adjacent, 18 is A. So O and A is TOA, tangents. So we'll jump straight into theta is equal to the inverse tangent of opposite, 23. Make sure you're putting the correct numbers in the correct places. Over adjacent. That's why I suggest labeling them. All right. Almost done, ladies and gentlemen. We're going to look at the inverse tangent, so functions, inverse tangent, back to main. We want that AB fraction. 23 is on top, numerator, and 18 on the bottom in the denominator. That 9 in the tenths is going to tell us to bump the 1 up to 2. We are going to have approximately 52 degrees. Hopefully this has helped. Hopefully the Desmos calculator is helping you as well. Please ask your teachers if you have any other questions.